Well, as you know, if you don't know the answer, always consult a friend. So in today's episode, I'm doing just that. Today I'm joined by Mike Whitehouse, fellow Microsoft trainer, as well as YouTuber MW Cloud in YouTube. So definitely check out his channel. It's awesome. Today's video is sponsored by RoboPack, the trend-setting solution for Intune packaging and third-party patch management. And it's free for SMBs and NGOs. Visit them today at robopack.com. So here's the deal, just before we start. We went through a really in-depth session on Docker and containers, and it was great. Problem was, it was too long. So what we decided to do is, rather than doing one video, I'm going to do two videos. So this first video will tell you everything you need to know about getting up and running with Docker, what containers are, how they differ from virtual machines, and really how to set things up. The second video will focus on containers in Azure and how Docker and some of its associated technologies can integrate into Azure. And we'll cover things like networking, additional development tools, and lots of extras. So watch out for that. That will be coming very soon. Now, if you've got questions and comments, as always, get those down below. And if you've not subscribed, you know what to do. Just click on that subscribe button up there. Ring that bell, and you won't miss out on the good stuff in the future. So I think without any further ado, let me introduce my very special guest, Mike Whitehouse. Hey, Mike. Great to see you, and a warm welcome to the channel.
Hi, Andy. Nice to see you too. And today, I think what we're going to do in this session is we're going to go through and have a look at a bit of Docker, because containers are really kind of important for us in the cloud today. And there's something that a few people need a couple of gaps filling in to see how they sort of fit in the picture in the modern administration perspective. So what's your kind of experience with Docker, Andy?
Well, I got to put my hand up for this one, Mike. I know nothing about Docker and containers. I know lots about virtual machines, virtualization, Hyper-V, and all of those things. But when it comes to Docker, I'm a complete virgin. So I'm sure, like many members of my audience out there, they're really going to appreciate this deep dive.
Oh yeah, certainly. There's multiple different ways of running containers actually in the Azure platform, from the very sort of simple way to the hugely complex way, and a couple in between there too. Today though, what I'm going to concentrate on is I'm going to concentrate on some Docker basics, some Docker container basics, and then I'm going to deploy a container into Azure in the simplest way possible through something called container instances. Now there are more advanced things from this. For example, there is things like Azure Container Apps and Kubernetes, both of which I actually have videos on my channel if you want to check those out. But for the moment, we're just going to do a bit of an introduction. But to understand these, initially we have to really understand Docker, and we really have to understand containers.
So an obvious question that I have to ask right away is, what is the difference then between a virtual machine and the idea of this Docker container?
All right, well, first of all, to explain that, let's go over to my whiteboard here so I can draw you a nice diagram. My videos and my demos, they run a lot on diagrams. So let's take a virtual machine, right? A VM. What's the purpose of a VM? Well, the purpose of a VM is to provide an isolated space for something to run. That's normally going to be your application or whatever service you want to run. And that application needs to be isolated so that it doesn't affect other things, and if it crashes, it won't affect other applications in that service as well. The thing with virtual machines is, when you're running your applications, you're going to need some form of operating system running inside there, a full version of Windows, and you're going to need some sort of hypervisor. Now that hypervisor, as you mentioned a moment ago, is going to be something like I can't even spell this morning, Hyper-V, or some people have things like VMware. And what these kind of hypervisor layers do is they put a layer or a software layer between your environment, your virtual computer, and your actual physical hardware underneath. Okay, so to provide this isolated space, this virtualized space, what the hypervisor is really doing is providing you things like virtual RAM, virtual CPU, virtual disks, and this is all great because you've essentially got a full computer running inside here that you've got complete control over. But there is also issues here, and one of those issues really is overhead. These applications might be quite small, they might be quite tiny, and you're running whole operating systems. You need a license for that operating system as well if you're running Windows, so that can cost a lot of money. These things can get quite large. Now, containers allow us to do the same sort of thing in isolation, but you don't isolate with hardware. So the way this sort of works is, initially you've got the hardware running on your computer, your physical CPU, your physical laptop, whatever it may be. You've got your operating system above that, and then what we need is we need a container engine, which to all intents and purposes looks a little bit like this, in the sense that it's a piece of software that actually will run our containers and provide isolation on our systems. Inside Windows or inside Linux, there are many different container engines out there, just like you've got things like Hyper-V and VMware. But the most common one that we actually find is something called Docker. Okay. There are others like Containerd, and they've all kind of risen to the surface in their own merits and advantages and disadvantages. For example, the thing with Docker and the thing with Containerd and containers in general is they're all standardized as well. There's something called the Open Container Initiative. Let's go run this. Here we go, this one. Open Containers. This is by the Linux Foundation. What this means is that whatever engine you use to create and build and run containers, they will be cross-compatible with all the other engines. Kind of like if I gave you a PDF file, Andy. I can make that PDF file in whatever software I wish, and you can actually go and open it in whatever software you wish, as long as the PDF file is the right standard and is all configured correctly. Same sort of thing here. So it doesn't matter if somebody's...
A good analogy there.
Yes, it doesn't matter if someone's using Docker or someone's using something else, but Docker is the kind of most common. So we've got a Docker engine. We've also got something called Docker Desktop, which makes our life a little easier, which is this thing. You can grab that from docker.com, download, next, install, nothing to particularly worry about. Now, the thing with this, to go and run these container systems, is that on Windows there's a little bit of an extra, okay? Now, when we run a container, I'll get to that point about it being an extra in a moment. When we run a container, what we have is we have an isolated space, just like a virtual machine. But we run a container from an image, okay? Now, I'm going to show you just how to run basic containers that you find on the internet. This Docker service down here is inherently hooked into a very special place called hub.docker.com, okay? This is known as a container registry. So on the internet, you may have seen places like GitHub, okay? Wonderful place. GitHub is for code. So you want to create Git repositories, publish them on the internet, have other people use them, you've got GitHub. Awesome. Say you want to do AI models. Well, you've got this place, Hugging Face. If you want to build your own large language models or build your own machine learning models and publish those for other people to use, this is the place you do that. Docker, on the other hand, if we go to this location, not www, but if we go to hub.docker.com over here, this is where people publish containers, all right? There are other places out there, and you can run your own container registries. That's not a problem, in the same way that you could run your own Git servers, not a problem. But this is kind of the main public location. And we'll see containers from all sorts of people here, like there's TensorFlow and PyTorch, there's Python container, and so on and so forth. What I want to do is I want to search for something here. There's millions of containers available for use. I'm going to search for WordPress, okay? Because
just as an obvious question,
yep.
I mean, are there costs involved here?
Not at the moment.
Okay.
Not at the moment. All of this is completely free, open sourcey at the moment. The way that people like Docker actually make money is the same as a lot of other open source companies, in that they provide the core product for free, but also provide enterprise grade additional software that can be charged and licensed and so on and so forth. For example, within Docker Hub, if you have an enterprise that's creating many different containers, then you're going to need somebody to host those and host permissions and make sure that the developers that are working on them all have appropriate permissions. Docker can provide those sort of services within Docker Enterprise as well. But the core technology, what I'm doing now, completely free. Okay, so if I search WordPress, what you'll find is there's a lot of these different container images, all right? And this is the key thing about Docker. It works on images. Now, on a virtual machine, right, what we might do is we might create a blank virtual machine to start with. We might take an ISO file, pop that in there, install Windows, connect this to the internet, pull down whatever software we need to pull down, and install our applications. Do a lot of manual configuration. That's not the case when it comes to containers. There's not a case of we do a manual configuration like that. We start off with base containers normally, but we might get to that later on. We'll see how this goes. In hub.docker.com, there is an image. Okay, let's use green actually. There is an image here called WordPress. For simplicity's sake, imagine this like a virtual hard drive file if you're used to virtual machines. It's not, it's a Docker image, but it kind of works in the same way. If I pull this image down onto my system, what I can then do is I can use that image to actually go and create and build out WordPress containers. But what's inside that image is quite special. So what's inside that image is you're going to get WordPress. WordPress as a framework is going to have a lot of other things around it. For example, it's going to need a database, it's going to need some config, it's going to need some other bits and bobs. It's also going to need an operating system to run on. Now here's the extra bit that I mentioned a couple of minutes ago that you need on Windows, right? These containers here, just like virtual machines, do need an operating system. 99% of these things are Linux. Now there are Windows containers, but they're only very specific use cases for Windows-based containers. 99% of these are running Linux as an operating system inside the container itself. And this is normally a teeny tiny cut down Linux, okay? Just enough Linux to run the application that you need to run. So if you go and look for Alpine Linux over here, something like this, okay? Alpine Linux is tiny. This runs in like 6 megabytes. Okay, it's really, really, really teeny tiny. And it's just going to be enough Linux to actually run the specific piece of software I need to run. Now, the other thing about this is this operating system over here on this virtual machine, that's completely isolated, all right? Because this is virtual CPU, virtual RAM, this is a whole other computer. This Linux down here is also sharing services from the core operating system. Now, I'm not running Linux here, I'm running Windows. So there is something on Windows that you do actually need for Docker Desktop to really work correctly. And that's to actually have, whoops, where is it? WSL installed on your computer, or Windows Subsystem for Linux. So if you're unaware of Windows Subsystem for Linux, it will install automatically when you install Docker Desktop. Okay, that's not a problem. It will just do it. It will just do it for you. If you want to do it yourself beforehand, go and have a look for WSL, not the World Surf League. That's a whole different lecture. So this one down here, how to install Linux on Windows with WSL. And you can just do that with the WSL -- install command. But that is a prerequisite for containers really to function on Windows itself. Now, Andy, you're on a Mac. You don't need this, okay? Because you've already got a Unix-based operating system running on your Mac anyway. You've got Mac OS, which is based off BSD. That's all cool. And if you are the kind of person who likes to run Linux as a desktop, well, you're already running Linux. So you're all cool there. All right. So let's go back over here. So how does this thing provide isolation? Here's where things get very different from VMs, right? So VMs are isolation on CPU and RAM. These are isolation on something called C groups. Okay. Now, I'm going to simplify this a little bit. If you open up a file or folder on your computer and you go to the properties of that, you've got an access control list, right? Now, imagine if you had an access control list for every single process that was running on your computer. Well, technically you do. You have different rings on a machine. What C groups does, in Linux anyway, is manipulates those processes to provide permissions. It's kind of a complex system to understand. You don't need to use it or don't need to understand it fully to understand how this actually works. In the same way that you don't need to understand how Hyper-V actually goes through and creates a virtual CPU. The documentation's there if you want to really read into how hypervisors actually function. But the key here is this is hardware level isolation. This is application level isolation. All right, that's the key difference or the key metric here. Now, because of that, that gives us a lot of flexibility. There's also some interesting stuff here. this container, and I'm going to spin this up in a minute and do a complete demonstration of this. Okay, it doesn't take too long. But this container itself actually has a full TCP/IP stack running inside it. All right, because I want to connect after I deploy this to this application running inside the container. Now, there's multiple different ways of doing networking, but the easiest way of doing networking in containers is to actually just do NAT. Just do network address translation. So this WordPress blog in the middle of it is going to be running on HTTP. Okay, just standard. In fact, let's do that. This is running on standard HTTP. I'm not doing HTTPS, so we're not going to do anything with the certificates at the moment. So Andy, what's the port for HTTP? Port 80, very good. So we've got port 80 running inside this container. What we're going to do is we're going to map that to a higher level port with natting. So a higher level port is anything over 1024. So the higher level port that we're going to map this to is port 8080. And what that means is when myself as a user down here comes in and attempts to access this service, I will do that through localhost 127.0.0.1. But if I go to port 8080, what that will do is it will route me into that WordPress blog down there. Now, because this has got its own separate IP stack, what this will allow me to do is get multiple of these going. So what I can do is I can take this WordPress blog over here, actually, whoopsie doodle, there we go, grab that, copy that, and then paste that out there. I can have a second one of these running perfectly fine. Now, on a normal computer, you can't have two things running with port 80. You can't have two things running on the same port at the same time. It's not going to work very well for you. But if we just change this high level port around to 8081, we can very easily have two containers running the same software at the same time. So we get to elastic scalability. So let's go run that. Okay, let's go work with this. So I've got a couple of things here. First of all, I've got my WordPress container. Okay, let's go and open that up. Okay, it's a Docker official image, which is great, which means it's all been certified and checked to make sure that nothing sketchy is inside it. Some of these have better documentation than others. Okay, this is the README file. There's a lot of stuff down here. Okay, defining how this container is actually going to run, what's inside it. There's also these things called tags, which are different labels, right? So if I really wanted, for example, version 6-PHP 8.1, I could have that. Or if I wanted 6.8 PHP 8.3, I can have that. I don't really want to deal with any of these at the moment. I just want to deal with the latest version of WordPress, and I just want to get this thing running, okay? So if I scroll down, I'm going to get some basic commands here. I'm going to grab this command, okay? That's the one I want. I'm going to copy that. I'm going to break this command down a bit. So I'm going to come over here into the terminal, and we're going to paste that in. Now, I could use Docker Desktop here to do this, but a lot of people interface with Docker through the command, or through the command line. So we've got Docker run, all right, which is go run me a container. Great. -- name, notice the two dashes, very Linuxy, is some WordPress. That's going to be the name of the container on my system. So if I'm naming, for example, Virtual Machine 1, you know, this is the name of that container that's going to be running. This P here is port. Now, this is where things get really confusing with this thing. So this is going into that. We are defining the external port and the internal port. The internal port is the application that's running inside the container. The external port is the one that I'm going to connect the container on. You can think of an external port as a unique identifier at the moment. Okay. Now, you'd think -D here, WordPress would be going into this -D thing. No. No, it's not. Okay, just to really confuse the process. There's two switches here. There's -D and there's -IT. Okay, because -D means daemon. What that means is go take this container and run it in the background as a service. Okay, I don't want to see it running. I just want it to run in the background. I'm going to connect to it with that port. Everything's going to be cool. -IT means interactive. Run this in the foreground and then give me a terminal so I can connect to it. This is really cool for things like dev spaces. Yeah, I'm going to do dev spaces with you as well. You'll love dev spaces. They're great. They're with VS Code. And yeah, they're really cool. So here's another thing that's quite confusing. This here, that is a full URL. Okay? A full URL. I know it sounds completely mad, but it is. The whole point is this Docker over here is inherently linked into this website. It's inherently linked into hub.docker.com. So what it's looking for a unique name. And over here, this WordPress container is completely unique. It just has that word WordPress. So if I run this command now, what's going to happen is it's going to look at my computer to see if I have a copy of WordPress or a copy of that image already installed. If I don't, it will go directly out to that hub.docker.com and it will go and pull it down. Now, if you have your own container registries, which you can deploy on Azure, I have a video on that one too, and you're going to push your own containers that you've developed to your own personal location, you don't have to use just a single word, you can use a full URL there. Okay, so if you're getting Microsoft containers, they normally start with mcr.microsoft.com/whatever, because Microsoft have their own container registry. Have you got any questions so far, Andy?
That's pretty good so far, mate. Doing great.
It's all making sense?
I am sure they're going to love it. It's perfect.
Is it making sense to you, Ben?
Absolutely. Very good.
Okay, great. So what we've got so far here is we've pulled down this WordPress container, or this container image, and it's now run. We've got a lot of stuff going on here. It seems to have pulled a lot of things. The reality is containers are like Lego. Containers are made up of multiple containers. So when I mentioned things before, like it's got Alpine Linux, it's also pulled that down for me. So if I get another container that runs Alpine Linux, it can do a check and say, hey, I've already got that bit. I don't need to download that. And they're all kind of separated, which is kind of cool. But this is now running. So if I do docker ps to show the current running containers, we can see this is functioning. If I look inside my Docker desktop here and go and have a look at my active running containers, there it is. There's some WordPress running, and it's running on port 8080. So if I open this on my local computer, WordPress running on my machine. Wonderful.
Very cool. Very nice.
Here's an interesting one for you. What about if I wanted another copy of WordPress? Think about elastic compute. Think about you want to spin more copies up when you get more users. You're going to need to put load balancers in front of this and everything. But what about the speed? Oh, the speed is good. Now, if I change this to some WordPress 2, because I'm going to need some uniqueness, I can't use that same higher level port. So I'm going to use port 8080 ROM. So, Andy, how long do you think it's going to take to spin up a new container? Now, I have a relatively fast computer here, but if you were doing this on something small, even something tiny like that, like a Raspberry Pi, it would still spin up just as fast as what I'm going to do. So, Andy, how long do you think?
Ooh, about 10 seconds?
It's not even seconds, because if you just watch this piece down here, okay, and watch this location, I'm going to go 3, 2, 1, enter on my keyboard, and there we go, it's up.
So when you think about that and you compare it with the likes of virtual machines, there must be quite a cost saving, surely.
Yes, definitely from a licensing perspective. If you're running a lot of Windows VMs and you're converting things to containers, there is other overhead costs to think about. For example, expertise costs. People have to learn this stuff. This is a relatively simplistic demo to get people started. There is a lot of complication to this. A lot of complication to this. This, from a desktop perspective, though, makes things really nice and neat. I'm just going to clear this down a bit. Let me give you another example of why you would want to use this on your own personal computer. Say there was something out there that you found and you wanted to go and play with. Okay. Say you've gone and discovered Graphanna. Okay, because Graphanna is becoming a big thing in Azure. Microsoft are kind of replacing a lot of their monitoring services with these Graphanna dashboards. And you're like, okay, cool. I want to go off and read about Graphanna. I want to go and play with it. Now, if you go into the Graphanna learning over here and you go into the tutorials for it, and you come down into Graphanna fundamentals, they do great tutorials with Graphanna here as well. You'll notice that these tutorials require the use of Docker because they give you a container with all the things in that you need.
And the last thing we need to talk about, Michael, is storage. So we've created the Docker containers, but how do we permanently store the content? Maybe you could walk us through that.
Containers are ephemeral. So if you go and look at the Cambridge English Dictionary down here, it says lasting for only a short time, which means that these containers are only running in memory. If I do anything unique to these containers, like for example, copy an index file in here, and now I start and stop, or maybe delete and rebuild this container, there's no permanence of storage. So to give you an example, let's just remove that running container. This would also be if your computer crashed and needed rebuilding, or if you need to reboot a server. If we go and run that container again, what we'll actually see now is we can refresh that. Welcome to Nginx. It's not permanent storage. So what we need some way of getting this index.html permanently into that directory. There's a couple of ways I could do it. I mean, I could rebuild the entire container with this index.html inside and have a new custom one. But maybe I'm working on developing stuff. Maybe I just want permanent storage. What I need to do is I need to kind of map that index.html to that directory path. Now we could do that in a couple of ways, but the easiest way is to use something called Docker volumes. All right. Docker volumes, if you come from the virtual machine world, they're a little bit like virtual hard drives. Okay. They're going to be unique storage space that we can map to a container. So what I can do is I can create within my Docker system a Docker volume, and I could, for example, maybe call that Docker volume something specific, and I could call this Docker volume, for example, nginx-data, and I could link this Docker volume to that specific path right there, so that anything contained inside that path, that user share nginx HTML, actually is stored down here inside this permanent Docker volume. Now my index.html is not going to be in here by default. I'm still going to need to get that information in there initially. So we'll just put this out to one side. Let's go do that process, shall we? So creating a Docker volume is quite easy. We just got to use this command. Docker manages where these are actually stored. There's different directory paths on Linux and on Windows and on Mac, so you can look those up. But if I just do Docker volume create nginx data, it's created that for me. You'll actually even see that here inside the volume section of Docker desktop. That's nice. So now if I come back into my containers, let's get rid of this nginx container again, and let's go and run this another time, but in a slightly different way. Okay, so we're going to use this docker run command again, but we're going to add an extra thing on here, a -v switch. And this is a volume switch. So this is where I can actually tell it where this information is stored. The volume I'm going to be using is just called nginx-data. I don't have to give a full path for that because Docker knows where these volumes are actually stored because it created it. Then I'm going to put a colon in there, just like we had port 8080 and port 80. And we're going to do /user, as usr /share/nginx/html. Okay, that's great. Now that is going to create this same container again, but it's also going to map that directory path to that specific volume here inside Docker desktop. So now again, if we open this up, we'll still see it says welcome to Nginx, so we still need to copy our information back in. So if I go into my copy command again, let's go insert that in. Great, so that's been inserted directly into the container called my nginx. But now this time, that index.html, yes, I inserted it here into the container, but the container's directory is mapped here into this volume. So the index.html is now living inside this volume. So if I refresh, I've got my custom website there. That's wonderful. But what I can also do is now I can stop and start that container and still have the same information. So if I go and delete that container now, and I go and rebuild this container, as long as I connect it to the correct volume where my information has been stored, run that again, when I come back to it, I can refresh it, I've still got Docker is awesome. Because if I go into these volumes, I can see I have the volume nginx data. And if I go into there, you can see there's my index.html file, the one that I actually copied directly in. So if you are using containers like Nginx, or you're using things like, for example, WordPress, you do have to kind of read the documentation to find out what directory paths the applications are using to store their information, so we can actually redirect those directory paths to some form of permanent storage.
So there you have it. Mike Whitehouse, thank you very much, sir. And as I've mentioned, this is part 1, so make sure that you tune into part 2. And this is going to cover things like Azure containers. We'll talk about a little bit about storage, networking, and really kind of enhance on this because Mike loves to talk. But anyway, remember, if you want to visit his channel, Mike in the Cloud, definitely check it out and show him some love because he's putting so much effort there. It's definitely worth it. Okay, that's it for this time. Thanks so much for joining me, and I'll see you next time around. You take care.